Let us now look at demultiplexers, and here is an example. We have one input pin, and in this example 8 output pins, O0, O1, O2 up to O7, and 3 select inputs, S2, S1, S0. Let us see how it works. A demultiplexer takes a single input I, this one, and routes it to one of the output lines, in this case O0, O1 up to O7. So in terms of functionality, it is exactly the opposite of what a multiplexer does. And if there are n select inputs, in this case n is equal to 3, then the number of output lines is 2 raised to n. So in this case we have 2 raised to 3 or 8 output lines. Let us now look at the truth table. S2 is the MSB and S0 is the LSB. So if S2, S1, S0 is 0, 0, 0, that is decimal 0, then the output line O0 is equal to I and all others are 0. So that means this input is routed to the output line O0. Let's take some other example, say this one. So S2, S1, S0 is 0, 1, 1 here. 0, 1, 1 is decimal 3. So the output line O3 becomes equal to I and all other lines are 0. So this I gets routed to O3 and so on. Alright, let us now illustrate the functionality of a demultiplexer with this circuit file here. So here is a demultiplexer, that is the input, and the input is a square wave signal, this one here, and it has got select pins S1, S0, it's called C1, C0 here, C for control, and the select lines are coming from this counter. So Q1 is connected to C1 and Q0 is connected to C0. And of course we are going to see later how this counter works. For now it is only supplying the select lines, and this is what our S0 looks like, and this is what our S1 looks like, and that is the input. Let us now see what happens. When S1 is 0 and S2 is 0, that means we have binary 0, 0 or decimal 0. The input gets routed to Y0, and that is what we see over here. This is our line Y0, and in this period the input has got routed to this line. When S1 is 0, S0 is 1, that means binary 0, 1 or decimal 1, X gets routed to Y1, that line, and therefore the input appears on this line in this interval here, and so on. So this is how the demultiplexer works. Let us now look at the gate level diagram of a demultiplexer. Here is a 1 to 8 demultiplexer or demux in short, and we have 3 select inputs, of course, because we have 8 output lines, and here is the corresponding gate level diagram. And in this circuit we have 8 gates, the same number as the number of output lines, and each gate gets 4 inputs. One of them is this input line I, that one, and then there are 3 others, and those 3 others are derived from S2, S1, S0, the select inputs. So these other 3 inputs can be S2 or S2 bar, S1 or S1 bar, and S0 or S0 bar. Now let us take some examples and see how it works. Let us take this example, S2, S1, S0 equal to 0, 1, 1. 0 1 1 is decimal 3, and therefore we expect the input line to get connected to O3 and all other outputs to be 0. So we expect O3 to be equal to I and O0, O1, O2, O4, O5, O6, O7 to be 0. Let us see if that is happening. Let us look at this gate O3. One of the inputs of course is I, and let us now look at these other three inputs marked in blue. This input is S2 bar. We can see that S2 bar. The second input is S1 and the third input is S0. And if S2, S1, S0 is 0, 1, 1, then all of these are 1, and therefore the output of this gate is simply equal to I. And you can verify that all these other outputs are 0. So that is how this demultiplexer implementation works.